is our focus today is on logs. So when we're thinking about our understanding of logs, we need to understand the relationship. So the relationship is looking at the inverse. And the inverse operation is our exponents, our powers. So we're going to start off by really unpacking this relationship, and this is going to help us with our understanding of our rules. So for example, a basic power is 2 base 2, the exponent is 3. 2 to the power of 3 is 2 times 2 times 2, which is 8. So I have 2 to the power of 3 is equal to 8. Another way I could write this, if I'm looking at the equation, is x to the power of a is equal to y. To look at the relationship, I really want us to go back and go to a basic log now. So our log is really talking about our base, and in this case our base here is base of 2. So log base of 2 is, what is our total, is 8. And that is going to give us our exponent, which is 3. So in the end, we're really just trying to find our exponent. And that is what log does. So we have to work backwards to work out what that is. Which that means we have our relationship, and I'm going to use our algebra now. So our algebra is stating that I've got the log of base x, a, is equal to y. Now let's go further and look a bit deeper at this. So this is where it's really important to understand all the rules. So with log, this is the basic fundamentals of it. The next step forward is understanding when we're adding log and also when we're taking away. So let's start off with something basic for now. I'm just going to think of a question that is log, exactly the same as this, log base 2 of 8 is equal, plus log base 2 of 8. Now, I really want to break this down, because this is saying, here, we know the exponent is 3, because 2 times 2 times 2 equals 8. So I know I'm going to technically get 3 as an exponent. Then I'm saying I've got another 3 exponents. So I've got the total of 6 exponents. So if I think about that in terms of my powers, I'm thinking that I have 2 to the power of 3, and I am timesing by 2 to the power of 3. If I've got 2 to the power of 3, it is saying we are adding the 3 extra 2's that we are timesing. So we are adding. And that's why it relates to this here. When we're still adding log, but this is the part where it changes. So we are adding our log to work out our exponents. But it actually means that we're timesing. Because if I look at this a bit further, if I need to go, this is 8 and this is 8. And I'm timesing them together. So if I go back to this now, it is actually meaning log base 2 of 8 times 8. So log of 2, 8 times 8. Well, 8 times 8 is 64. So that's saying the log of 2 of 64 is equal to my 6. Now let's double check that, because it's all about our understanding and that relationship. The relationship is key. So to start off, I'm going to have my base of 2, my power of 6 is equal to 64. So let's double check this. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And 6 times 2 is 64. So, and there we have it. We've seen that relationship with addition. Now, let's go a bit further. I want to cut this part off. And look at the relationship in terms of takeaway, subtraction. It's exactly the same. So let's get started. Likewise, I'm going to start off with log base 2 of 16. And I'm going to, again, take away log base 2 of 4. Because it's really about making sure we're understanding that relationship. So to start off, I'm just going to think about it, and then I'm going to make that relationship. So if I look at this first part, log 2 of 16 is thinking, what will be my exponent? Well, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So that means that is saying I've got 4. And I'm taking away base 2 of 4. Well, 2 times 2 is 4. So that is saying 4 take away 2 equals 2. Now keep that in mind, because that is going to help us with us unpacking this. So we already know the answer. Now let's go a bit deeper in relation to this. So I'm again going to think about this separately. And then we're going to look at that relationship. So here, I can see 2 to the power of 4 is going to be equal to 16. And I am saying log 2 to the power of 2 to the power of 2 is equal to 4. So really, when we're taking away log, it's like we are dividing. So we're dividing out with our index log. That is saying we've got 2 to the power of 4, and I'm dividing by 2 to the power of 2. So now our rule's starting to come into effect. So likewise before, when we've got this, when we're dividing with exponents, we are subtracting. And that's why we are subtracting our log, which is here. But that means we are also dividing our actual amounts. So that means I can go, I will clear this part here. That means I'm able to go log of base 2 is 16 divided by 4. I know 16 divided by 4 is 4. Which means I'm going to get the answer of log base 2 of 4. 2, what power does it need to get 4 is 2. So this is going to equal 2. So that's helping us out right now. Let's have a look at this. If I'm dividing 2 to the power of 4 divided by 2 to the power of 2, I'm subtracting my powers. 4 take away 2 is 2. So I get 2 to the power of 2. And that's what my exponent tells me. I've got a power of 2. 2 to the power of 2 is my 4. So again, we're seeing that relationship. Okay, I'm just going to rub this off. Hopefully you have written down and taken some notes, because we are going to go to the next step. Now I want us to really think about a deeper relationship. So we're really understanding now how to multiply and divide with our exponents and relate it to our logs. Now I want to go the next step. So for example, I'm going to start off with log, still keeping it as base 2. So log base 2. I am going to make it 16. Log base of 2 is 16. So that just means it's going to be 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So the answer is 8. I want us to really focus on this relationship because we are able to break this 16 down by really looking at, well, 16 is the same as 4 to the power of 2. So I'm making it simpler, but that means I've also got an exponent here. So let's have a look at this. That means this 2 will be going on to the outside. And it becomes 2 log base 2, 4 is equal to 8. Okay, now the next step that we need to think about, and this is going to help us solve this. If I look at log 2, 4, what exponent does base 2 need to have to get to 4? That's our question. So the first thing I think about is it's going to be log 2 of 4 is 2 times 2 is 4. So then this log 2 of base 4, which means that is going to be 2, and I've got 2 times 2 equals 4. So this is where I made a mistake here before because I wrote 8 here when it was supposed to be 4. So that's my mistake. I said it, but I just wrote down the wrong thing. So because if we look at this, 2 to the power of 4 is 16. Now I did the working out, but that's where we can make mistakes sometimes. So log 2 of 4 is 2. 2 times 2 is 4, which is what we got. So it's really about understanding that relationship. Now the same thing can occur in terms of us understanding fractions. So for example, if I have log of 1/4, this is where we need to understand our negative indices. I can rewrite log base of 2 1/4 by saying I've got log base of 2 4 to the power of -1. I am able to then take the -1 to the front. And that becomes negative log 2 base of 2, 4. So that this must mean log 2 of 4 has to equal to 2. Because 2 times 2 is 4. And then 2 times -1 must equal -2. So we're starting to get into negatives as soon as we start looking at a fractional amount with a log. I really hope this is helping you understand logs a bit more in terms of not just breaking it down, but that relationship. Because in the end, exponents, it really comes down to understanding the relationship with log and being able to move between them. If you can do that, it's going to help you to be able to apply your understanding.